Have you ever wondered, what it would feel like to look into the darkness of space and see, not emptiness, but life? Not just distant light, not just chemistry, but a signature, soft, undeniable, of something alive, breathing under an alien sun. You see, when the James Webb Space Telescope began its watch, we expected to see the familiar: clouds of gas, faint galaxies, and the slow unfolding of cosmic time. But, well, it showed us something else. Something that makes even the most rational scientists stop and stare. In the light of a distant world, K2-18b, orbiting a red dwarf star in the constellation of Leo, Webb detected something extraordinary. A pattern in the light, a set of chemical fingerprints that could only be made by life. Methane, water vapor, carbon dioxide, and one molecule that, on Earth at least, has a single source, dimethyl sulfide, made only by living things. The data suggest a 99.7% probability, almost certain by scientific standards, that what Webb saw wasn't coincidence. It was a whisper from another biosphere. And that's the thing, you know. This isn't a story about aliens, or miracles, or imagination. It's about nature. About physics producing biology the way rain produces rivers. As Brian Cox once said, we're not searching for magic. We're discovering nature in its most miraculous form. So perhaps, the question isn't, are we alone? But rather, how could life not exist elsewhere? When the universe gives you oceans, warmth, and time, life seems inevitable. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. And, I'd love to hear from you. Where are you listening from tonight? It's always fascinating to see who's joining us from all around the world. So let's continue. When the James Webb Space Telescope opened its golden eyes for the first time, it wasn't simply looking outward. It was, reaching backward, through time itself. Every beam of infrared light it captured wasn't just distance measured in light years. It was memory. It was the universe remembering its own creation. Brian Cox once said that when we look deep into space, we are also looking back through time. And Webb? Well, Webb is humanity's most extraordinary time machine. It stretches the human gaze beyond imagination, beyond the faint whispers of ancient starlight, into the first chapters of existence itself. This telescope doesn't see like we do. It listens to warmth, to wavelengths invisible to the naked eye, to the faint afterglow of galaxies born billions of years before Earth had oceans or breath. Infrared light passes through dust, through the shroud of creation, revealing what no optical telescope ever could: the nursery of stars, the birthplaces of planets, the chemistry of alien skies. The brilliance of Webb lies not just in what it sees, but in how it sees, by reading light as language, by turning color into meaning, by transforming silence into story. And, perhaps that's the most astonishing thing. Every spectrum Webb records isn't merely an image, it's a signature. Light broken apart into its elements, revealing fingerprints of molecules across unimaginable distances. Hydrogen, methane, water vapor, carbon dioxide, simple, universal notes in the grand symphony of chemistry. When Webb points at an exoplanet, it doesn't just capture its face, it listens to its atmosphere breathe. And, well, that breath may one day tell us we're not alone. It's strange to think that this vast metal eye, suspended 1 million miles from Earth, was built not to conquer, but to listen. Its mirror, a mosaic of gold-coated hexagons, gathers light older than humanity, older than the sun, older even than the Milky Way itself. It's not a machine of conquest, it's a vessel of humility. It reminds us that the more we see, the smaller we become, and yet the deeper we belong. The paradox of discovery is that it expands both the universe and the heart. Well, and then there's the idea of time. Time behaves differently when you look with Webb. What we see in its deep field images, the galaxies swirling like silent fireworks, those aren't now, they're then. The light left them billions of years ago, before Earth was dust. When Webb observes them, it's like hearing an echo so faint you can barely tell its sound at all. But that echo carries everything. The birth of stars, the first atoms cooling from the Big Bang, the spark of structure forming out of chaos. That's why scientists sometimes call Webb a time machine. Not because it moves through time, but because it reveals time as it truly is. A woven tapestry where past and present coexist in the same light. We don't just observe the universe, we participate in its unfolding. The photons that left a galaxy billions of years ago now end their journey inside a human-made mirror, completing a story that began before life existed. And, this is where it becomes philosophical. Because the telescope isn't only about exploration, it's about reflection. When Webb peers into a distant nebula, it's not just searching for answers about how stars form or planets evolve. It's asking a quieter, more human question. Where did we come from, and how much of that origin still lives within us? The light Webb captures is the same light that forged our atoms. The stars it observes are our ancestors. That realization humbles even the most logical minds. Science, in its precision, often forgets to pause for wonder. But Webb refuses to let us forget. Its images, the Carina Nebula, the cosmic cliffs, the pillars of creation, are not just data. They are poetry written in light. Every swirl of gas and dust is a verse in the long poem of existence. We can analyze them, measure them, model them, but we also, inevitably, feel them. And, Brian Cox said something like this once, that when we study the universe, we're not discovering something foreign. We're rediscovering ourselves. It's not that life is rare. It's that life is the universe remembering what it can be. Webb, in that sense, is not an instrument of astronomy. It's an instrument of memory. It holds a mirror up to the cosmos and asks it to remember itself through us. Every photon Webb catches has traveled across unimaginable distances and unimaginable time, yet it ends here, in our moment, translated into color and form. That's the quiet miracle. The telescope doesn't just show us the past, it completes it. The light it receives only becomes real when consciousness sees it. And, in that act of seeing, the universe becomes aware of itself. So when we call Webb a time machine, we're really describing something deeper. It's not just mechanical, it's metaphysical. It doesn't bend time, it bridges it. It connects the first second after the Big Bang with the breath you're taking now. The journey of light is the journey of everything becoming aware that it exists. Well, there's something fragile about that idea too. Because Webb is, in its way, temporary. It will one day fall silent, its mirrors cooled to darkness. But the knowledge it leaves, the perspective it gives, will echo for generations. It reminds us that progress isn't about speed or conquest. It's about alignment, aligning the precision of engineering with the patience of the universe. And, in that alignment, something like grace appears. That grace is what makes Webb feel alive. It's not just steel and circuits. It's purpose and curiosity embodied in form. Every calibration, every observation is a dialogue between human ambition and cosmic history. The telescope isn't simply studying the universe, it's participating in it. We forget sometimes that light is fragile too. It can scatter, it can fade, it can vanish into noise, and yet some of it survives, crossing billions of years to find a receiver. It's almost as if the universe wants to be known, wants to be seen. Webb doesn't just fulfill that desire, it honors it. The universe isn't a secret waiting to be solved. It's a story waiting to be remembered. And, well, that story doesn't belong only to scientists. It belongs to everyone who's ever looked up and wondered. Webb extends that wonder into the realm of the tangible. It takes the invisible and makes it visible, the ancient and makes it present, the cosmic and makes it intimate. It's not just about what's out there, it's about what's in here. So perhaps that's what makes Webb humanity's greatest time machine. Not its ability to travel through time, but its power to make time visible. Every image is a conversation across eons. Every discovery a bridge between what was and what will be. The telescope doesn't just expand our universe, it expands our sense of belonging within it. And as the golden mirrors continue to capture the faintest whispers of creation, there's this quiet, almost sacred awareness that we're not merely spectators of the cosmos. We are participants in its remembering. And somewhere, in the next chapter, beyond the reflections of starlight, beyond the edge of what even Webb can see, awaits the first true sign that we were never alone at all. When Webb turned its mirror toward the constellation of Leo, something quietly revolutionary began to unfold. The telescope, patient as ever, stared into a faint point of light. Just another star, small and red. Nothing that should have stood out. But orbiting that dim sun, at a distance neither too close nor too far, was a world that would soon change everything we thought we knew about life itself. K218b. It sounds almost clinical, almost detached, a string of letters and numbers. But, what Webb found there carried the pulse of possibility. Well, to begin with, this planet sits about 120 light-years from Earth. That means the light Webb sees left it long before modern humans walked the planet, long before our species even dreamed of looking outward. Every observation of K218b is, in a sense, a conversation with the past. Yet what it reveals feels startlingly current, almost urgent. The planet isn't enormous like Jupiter, nor is it small like Earth. It occupies a delicate in-between space, a super-Earth, massive enough to hold onto a thick atmosphere, but not so large that it becomes an ice giant. It's a balance, a quiet harmony between extremes, and perhaps that balance is exactly why it feels so significant. The atmosphere Webb detected there, thick with hydrogen, wasn't supposed to exist around a world that could harbor life. Hydrogen, light and volatile, usually belongs to the gas giants, worlds too large, too alien. But here, in this strange and stable world, hydrogen does something different. It acts as both a shield and a cradle. It traps heat just enough to keep the temperature steady, around 49 degrees Celsius, or about 120 degrees Fahrenheit. Warm, yes, but not unbearable. In cosmic terms, it's gentle. It's, perfect for chemistry to breathe. That stability is not accidental. It's the product of balance between the faint warmth of its red dwarf star and the chemical choreography of its sky. Hydrogen rises, heat circulates, and the entire atmosphere hums with equilibrium. The The planet doesn't seem wild or chaotic. It seems deliberate, as though nature itself had tuned it to sustain possibility. Not just random, but rhythmic. Not just functional, but elegant. And, Brian Cox once said that when we study the cosmos, we're not witnessing miracles. We're witnessing nature at its most miraculous. That thought feels truer here than anywhere. Because K2-18b, with its soft hydrogen haze, seems like a world built not by accident, but by inevitability. The universe, given time, produces conditions where life can begin. Not as a rare exception, but as a natural rhythm of existence. When Webb's spectrograph separated the light from that planet into its components, what it found was more than chemistry. It was character. Methane, water vapor, carbon dioxide, even the faint signatures of dimethyl sulfide, a molecule that on Earth comes only from living organisms. Those signals would grow clearer later, but even now, in this early observation, there was a whisper, a sense that the planet wasn't silent, that something there was breathing, even if softly. The discovery raised questions, of course. Could hydrogen-rich worlds support life as we know it? Or would any potential organisms there be unlike anything we can imagine? Creatures whose biology follows rules beyond Earth's biochemistry. Scientists began to rethink everything. Life, it turns out, might not need oxygen at all. It might not need sunlight as we understand it. It might not even need a surface. Well, imagine that. The possibility of life floating, not walking, in layers of atmosphere sustained by chemistry instead of photosynthesis. On K2-18b, that idea doesn't feel far-fetched. The hydrogen keeps the air thick, like a vast ocean of gas. Somewhere within that depth, heat and energy might combine, driving reactions the way sunlight does here. If Earth's oceans were the cradle of life, K2-18b's skies might be theirs. And, well, this is where it becomes both scientific and spiritual. Because it's not just about another world, it's about another pattern of being. The more we look, the more it feels like the universe is repeating itself. Not in exact form, but in principle. Stability, chemistry, warmth, complexity, all woven together in the same quiet rhythm that made us. The more Webb reveals, the more it feels like life isn't a miracle at all. It's a consequence. Of course, that doesn't make it less beautiful. If anything, it makes it more so. Because what could be more poetic than a universe that creates consciousness simply by following its own laws? Hydrogen becomes water. Water becomes motion. Motion becomes memory. The pattern continues until one day, someone on a blue planet points a mirror at the sky and begins to wonder who else is wondering. And, what's fascinating about K2-18b is not just its chemistry, it's its calm. Around many red dwarfs, planets are bombarded by flares, radiation storms that strip atmospheres bare. But here, the star K2-18 is quiet, serene. It burns cooler, steadier, and, it ages far more slowly than our own sun. That means the planet around it has time, billions, maybe trillions of years, for life to begin, evolve, and endure. We may be newcomers in comparison. Life there, if it exists, could be ancient beyond comprehension. That, some that thought, unsettles and comforts in equal measure. It means the universe isn't racing. It's patient. It's not hurried by clocks, but guided by chemistry. K2-18b could be an ancient ocean of clouds where evolution has no reason to rush. Perhaps intelligence there wouldn't build telescopes or technology. Perhaps it would simply exist, aware, balanced, quiet. quiet. Well, and that leads to the paradox that Webb forces us to face. We're always looking for life that looks like us. Oxygen breathers, water drinkers, tool builders. But maybe life is far broader, far stranger. Maybe it doesn't need to resemble Earth to be alive. Maybe, the cosmos is full of existences that don't even know what alive means in our sense, and yet they thrive. So when we call K218b a world between two extremes, it's not just about size or distance or temperature. It's about philosophy. It sits between what we know and what we can imagine, between Earth and Neptune, between biology and chemistry, between science and wonder. It's a threshold, a hinge between the possible and the unthinkable. The beauty of it is that we found it not by accident, but by attention, by listening closely to faint starlight and believing that within its whisper, something meaningful waited. Webb didn't discover K218b as a miracle. It confirmed it as a pattern that suggests life may not be an isolated event, but a cosmic habit. As light from that planet traveled 120 years through space to reach Webb's golden mirrors, it carried more than data. It carried a message that the universe has been writing stories of balance and breath long before we were here to read them. And now, as we decode them, line by spectral line, we begin to sense the enormity of what that means. And, somewhere in that meaning lies humility. Because if K218b can exist, stable, warm, cradled in hydrogen, and if life can breathe there, then everything we thought was rare becomes common. The miracle becomes the norm, and the norm becomes miraculous. Well, maybe that's the quiet revelation Webb gives us. Not proof, not certainty, but continuity. The same physics that shaped Earth shapes distant worlds. The same chemistry that built our bodies is written across the stars. And the same longing that made us look upward is the same force that binds galaxies together. So as we stand at the edge of this new discovery, in this strange and humbling year of 2025, it's not just about confirming life, it's about redefining it. K218b, that world between two extremes, becomes a symbol of what lies ahead. A reminder that the search for life is not just about finding others. It's about rediscovering ourselves piece by piece, reflection by reflection, as the telescope continues to gaze deeper, pulling us gently toward the next question waiting in the dark. When the first spectra of K218b arrived, lines of color split like threads of thought. Something extraordinary appeared between them. It wasn't just light refracted through gas. It was, well, something alive. Not in the sense of motion or pulse, but in the unmistakable imbalance of chemistry, the kind of asymmetry only life can maintain. Webb's instruments, those gold eyes stretched across the void, detected a pattern that defied equilibrium. There was methane where there shouldn't be, carbon dioxide at levels that didn't make sense, and water vapor that, breathed in and out of the atmosphere as if responding to some unseen rhythm. But the real revelation came from a whisper of a molecule, a faint but precise signature of dimethyl sulfide. That compound is, on Earth, only made by living organisms. Plankton in our oceans release it. It becomes part of the air, a trace left by breath itself. So, when the signal appeared in the light of a distant world, hundreds of trillions of kilometers away, it was like hearing an echo of something deeply familiar. Webb wasn't just looking at chemistry anymore. It was listening to biology. It was like the universe had cleared its throat and spoken, very softly, in a language we were only just beginning to understand. Well, scientists, cautious as ever, hesitated to call it life. But they couldn't call it coincidence either. The mixture of methane, carbon dioxide, and dimethyl sulfide didn't align with any known geological process. It wasn't equilibrium, it was deviation. And, deviation is the hallmark of life. Because life doesn't rest in balance, it thrives in disequilibrium. Every cell on Earth, every breath we take, depends on maintaining that imbalance. Oxygen consumed, carbon released, heat exchanged. That, constant motion, that defiance of stasis, is what separates the living from the inert. So Webb, by reading that imbalance across the light of a distant star, was, in a sense, witnessing metabolism on a planetary scale. The planet wasn't dead rock, it was reacting. Something there was doing chemistry with purpose. And that realization cracked open everything. Because for decades, we'd searched for life by looking for water, for warmth, for Earth-like comfort. But here, in this strange hydrogen-rich world, the story was entirely different. The chemistry didn't mimic ours. It rewrote the script entirely. And, well, it made us ask, what is life, really? Is it carbon-based, oxygen-dependent, blue planet-bound? Or is it something broader, something universal, woven into the logic of physics itself? That, question lingers like starlight long after the telescope turns away. Brian Cox once said that biology is chemistry with ambition. And Webb's findings on K218b proved that ambition doesn't belong to Earth alone. The molecules there weren't behaving randomly. They were aligning, forming, persisting. In every direction, the telescope found evidence of systems resisting entropy. The second law of thermodynamics may still rule the universe, but in these delicate microcosms, order pushes back. That push, against decay, against silence, is what we call life. Imagine it. Somewhere beneath that hydrogen sky, chemical reactions ripple like tides, invisible yet relentless. No sunlight, no forests, no oceans, just layers of gas, each one a microcosm of potential. Hydrogen acts as a blanket, trapping warmth from the faint red star, and beneath that warmth, chemistry dances. Molecules collide, merge, split, reform. It's not chaos, it's choreography. That constant rhythm might be the heartbeat of an alien biology. And, maybe it doesn't look anything like us. Maybe it doesn't even know what alive means. But it moves. It persists. It transforms energy into continuity. And isn't that the essence of being? Whether it breathes or drifts or thinks doesn't matter as much as the fact that it endures. That, endurance is the oldest story in the cosmos. The drive to stay against the pull of nothingness. So when Webb sent back that data, those lines and dips on a spectral graph, scientists weren't just interpreting wavelengths. They were decoding an autobiography of a world, a biography written not in words, but in molecules. The dimethyl sulfide line was faint, yes, but it carried meaning beyond its strength. It meant that the universe might not only make life, it might repeat it. Over and over again, wherever the conditions whisper, maybe. The discovery sent shockwaves through every field. Astrobiologists recalibrated models, chemists rewrote equations, and philosophers, well, they began to tremble at the implications. Because if life can emerge in hydrogen-rich atmospheres, then the rules we thought defined existence are far too narrow. It's not just carbon and oxygen anymore. It's balance and energy and time. It's the physics of persistence. The The cosmos may not just allow life, it may require it. And, there's something almost poetic about that. Because the dimethyl sulfide wasn't loud, it wasn't a shout across the galaxy. It was a whisper, the faintest signature, hiding between layers of gas, nearly drowned in noise. Yet Webb heard it. Humanity heard it. That moment was quiet, but it carried the weight of every myth, every question, every gaze turned upward since we first saw the stars. What makes it so haunting is that it wasn't proof. It was presence. Not a discovery, but a reminder. The molecules didn't say, "We are here." They said, "We are possible." And sometimes, that's more powerful. Possibility keeps the universe alive. Certainty ends the story. Uncertainty lets it breathe. Well, and it wasn't just the chemistry that mattered. It was the rhythm of change. Over time, Webb observed shifts in the spectra, slight variations that hinted at cycles, perhaps seasons, perhaps biological flux. The atmosphere of K218b wasn't static. It pulsed. It changed with time, suggesting processes unfolding beneath, processes that followed their own slow, steady clock. It wasn't noise. It was life's subtle heartbeat. That realization changed how we listened. It reminded us that life doesn't announce itself. It emerges. It doesn't declare. It accumulates. And Webb, in its silence, became the perfect listener. Through patience, through precision, it captured what the human eye could never see. Not light, but the persistence of living chemistry across unimaginable distances. And, it made us rethink not just the question of where life is, but what it means to be alive. Maybe it's not intelligence or awareness that defines it, but pattern, repetition, response, resilience. A planet that breathes through its chemistry, that maintains imbalance against the pull of entropy, that adapts its atmosphere over millennia. That planet, in its own way, lives. So perhaps we've been looking for mirrors when we should have been looking for echoes. Life doesn't need to reflect us to exist. It only needs to continue. The signal Webb found on K218b might not resemble the biology of Earth, but it resonates with the same rhythm, the same defiance of stillness. And when the data faded, when the telescope turned its golden gaze elsewhere, that rhythm stayed. It lingered, like the afterimage of a thought, reminding us that somewhere out there, chemistry had crossed a line and become something more. And that, something more, is what drives us forward, to keep searching, to keep listening, to keep asking what else might be waiting beyond the next world Webb will reveal. When the data from Webb reached the scientists' screens, it wasn't just numbers and graphs. It was something like a heartbeat, a pattern pulsing through the noise. The measurements repeated themselves again and again, so precise, so deliberate, that even the most skeptical researchers had to pause. What they saw wasn't faith, it was consistency. That rhythm, that near-perfect match between theory and observation, brought humanity to a strange new threshold, where evidence begins to feel like belief. Well, the signal from K218b was analyzed, cross-checked, recalibrated, and, tested against every known source of error. Instrument noise, cosmic interference, data compression artifacts, everything was stripped away until only the truth remained. And that truth carried a number, 99.7%. In the language of science, that is called a 3 sigma detection. In simpler words, it means that out of 1,000 tests, fewer than 3 could be wrong. It's not certainty, but it's the edge of it. The line where evidence begins to whisper, trust me. The thing about 99.7% is that it's not magic. It's method. It's the same statistical confidence physicists used when they discovered the Higgs boson, when gravitational waves were confirmed, when quantum mechanics stopped being theory and became fact. And now, that same threshold, the same quiet mathematical voice, was saying that the light from K218b carried the unmistakable breath of life. It wasn't faith, it was measurement, not hope, but precision. And, yet, as Brian Cox once said, even the most rigorous numbers cannot protect us from wonder. Because science, at its best, doesn't replace awe, it refines it. The 99.7% confidence level didn't erase mystery, it framed it. It turned maybe into almost certainly, and in doing so, made the cosmos feel both closer and stranger. We stood on the bridge between skepticism and reverence, where data begins to sound like revelation. Some scientists hesitated. After all, 99.7 isn't 100. There's still that 0.3%, small but present, the gap where uncertainty breathes. And maybe, just maybe, that's where curiosity lives too. Because without that sliver of doubt, exploration would end. If we ever reached 100% certainty, we'd stop asking questions, stop peering into the dark. The beauty of science lies in its willingness to remain unfinished. Still, that number, 99.7, echoed through every lab, every observatory, every discussion on Earth. It wasn't proof, but it was persuasion. And, persuasion is what moves minds. Webb had turned light into probability, and probability into possibility. For the first time in human history, we weren't just speculating about life beyond Earth. We were quantifying it. That shift changed everything. Philosophers began to argue about what it meant to know. Theologians whispered about divine equations. Politicians wondered if policy could prepare for contact with something not of this world. And scientists simply smiled, because this is what they'd been waiting for. The day numbers began to sing. Well, the process behind that 99.7% is delicate, even poetic in its precision. Imagine 1,000 photons leaving a distant world, traveling 120 light years, each one carrying the faintest trace of chemistry, the faintest story of an atmosphere. When they reach Webb's mirror, they scatter, refract, and become data. Those data points, once translated, form a spectrum, a rainbow of meaning. And, in that rainbow, scientists look for patterns that shouldn't exist by chance. Dimethyl sulfide, for instance. It leaves a very specific fingerprint, a dip in the light, narrow and distinct. The odds of that pattern appearing randomly are less than 1 in 1,000. Combine that with methane and carbon dioxide imbalance, and the probability tightens further. Add the water vapor layer that shifts slightly over time, and you get a sequence so consistent it stops being coincidence. The universe doesn't play dice that neatly. Something there is maintaining order, repeating process, sustaining difference. And, the moment that realization dawned, humanity's relationship with evidence changed. We stopped thinking of life as an exception. We started seeing it as expectation. It's not just that we found a planet that might host life. It's that we found a pattern that predicts it. K218b isn't a miracle. It's an equation, a result, a consequence of physics repeated across time and space. Yet even in that precision, emotion crept in. You could hear it in the way scientists spoke, the way their voices trembled when presenting data that didn't just describe a world. It described possibility. Because numbers can be cold, but their meaning can set hearts alight. The The universe was beginning to feel less like an empty stage and more like a conversation. And that conversation, between data and meaning, between probability and awe, carried the sound of transformation. The old divide between science and belief, between knowing and feeling, began to blur. We realized that the two aren't opposites, they're companions. Science tells us how. Wonder asks us why. Together, they build understanding. Well, and in that understanding came humility. The 0.3%, the fraction of doubt, became a sacred space. It reminded us that knowledge without uncertainty isn't wisdom, it's arrogance. The uncertainty keeps us human. It keeps us searching, listening, refining. It makes science not an answer, but a dialogue. And, perhaps that's what Brian Cox meant when he said that science isn't about finding miracles, but about finding nature itself in its most miraculous form. The discovery on K2-18b wasn't divine intervention, it was divine inevitability. When the laws of physics are allowed to run their course, life isn't a surprise, it's a pattern waiting to be seen. So what does 99.7% really mean? It means we are standing closer to truth than ever before, but not yet touching it. It means that the line between believe and know has never been thinner. It means that when light travels across the void and enters our instruments, it doesn't just carry information, it carries intention, as if the universe is gently insisting, see me, understand me. And maybe that's the deeper truth Webb has revealed. Not just that there is life out there, but that the cosmos itself seems to want to be known. Every photon that reaches us is a messenger, every spectrum a confession. And we, the listeners, are learning to translate its language. That language is precise, but it's also poetic. The numbers, 99.7, aren't just confidence intervals. They're metaphors for faith measured in decimals. Faith, not in divinity, but in reason. Faith that the universe behaves consistently enough for us to trust its whisper. And, if that's the case, then maybe faith and science aren't enemies at all. Maybe they're reflections, one emotional, one empirical, of the same human yearning to find connection in the infinite, to reach beyond uncertainty and touch something enduring. Well, and that's where the line between knowledge and meaning begins to dissolve. Because once you reach 99.7%, the question isn't, is it true? But, what will we do with it? If life exists beyond us, then the story of Earth is no longer singular. It's shared. The discovery doesn't just expand our universe, it expands our identity. And so in this strange, shimmering threshold between proof and wonder, humanity takes its next step. Not just as observers, but as participants in a living cosmos. And, as Webb turns its golden eyes to new worlds, chasing signals even fainter, even further, that small margin of uncertainty, the space between numbers and belief, will continue to guide us into the next great revelation waiting in the dark. When scientists first imagined life beyond Earth, they drew lines around what seemed possible: oxygen, carbon, sunlight, liquid water. Everything else, everything alien, was dismissed as improbable. But K2-18b changed that. Its atmosphere, thick with hydrogen, turned old definitions into questions. Hydrogen was supposed to suffocate life, not sustain it. It was supposed to strip planets bare, not cradle oceans. Yet there it was, a world stable, temperate, whispering with chemical imbalance, alive with implication. Well, at first, it didn't make sense. The textbooks said that hydrogen-rich worlds couldn't host life because, hydrogen reacts too easily. It escapes, it erases complexity. But the more Webb observed, the more it seemed that hydrogen wasn't an obstacle, it was a framework. That realization broke something open in our thinking. Hydrogen wasn't just the simplest element, it was the first. It filled the early universe long before carbon or oxygen were born in stars. So maybe life, the very first life anywhere, didn't start with water or oxygen. It started with hydrogen. And, that idea turned the search for life upside down. We used to look for planets like Earth. Now, we began to look for planets like possibility itself. Because if hydrogen could sustain complexity, if it could carry chemistry that breathes, metabolizes, evolves, then life might not be rare at all. It might be the natural state of things. The chemistry on K2-18b told a story far beyond Earth. In the layers of its atmosphere, scientists found traces of reactions that could recycle energy through hydrogen bonds. Molecules formed and reformed, storing heat, releasing it, stabilizing temperature like a global metabolism. There were signs of cycles, feedback loops that mirrored the way Earth's biosphere regulates itself. The planet seemed to breathe, not through lungs or leaves, but through chemistry itself. That realization gave rise to a new term, hydrogenic life, a biology not bound to oxygen, but free to evolve in hydrogen-rich environments. The more researchers simulated it, the more it made sense. Hydrogen could act as both solvent and shield. It could carry nutrients, distribute energy, and, absorb radiation that would otherwise destroy delicate molecules. Where we saw poison, nature might see protection. And, well, this led to a deeper thought, that maybe life is not defined by ingredients, but by patterns. The pattern of persistence, the rhythm of energy cycling through matter. Whether it's oxygen or hydrogen doesn't matter. It's the motion that counts. Life, in this sense, isn't a recipe. It's a behavior. The universe doesn't choose elements. It chooses endurance. Hydrogen worlds like K2-18b could in fact be more stable than Earth. Our planet's oxygen-rich air is volatile. It corrodes, burns, breaks apart easily. Hydrogen, though reactive, can maintain equilibrium over eons when balanced with other gases. The result is longevity. That means if life began there, it could last not for millions, but for billions of years, evolving slowly, quietly, beneath the protection of its gentle red star. And, think about that. Think about a world where evolution doesn't rush, where creatures, if they exist, grow at the pace of mountains, where intelligence, if it ever arises, has time, not just centuries but eternity, to reflect, to adapt, to become. We grow older, clocks tick, but on a hydrogen world, time itself feels different. It stretches, it softens, it forgives mistakes. That, calm could produce life beyond our imagination, not carbon-based, perhaps not even molecular in the way we know it. Maybe networks of energy exchange, fields of chemistry that act like consciousness without ever forming cells. Maybe thought as reaction, memory as resonance. The idea feels impossible until you realize that on a cosmic scale, the impossible is just the unobserved. Well, Brian Cox once said that the universe is not designed for us. It simply allows us. And if it allows us, it must allow others. The discovery of hydrogenic life possibilities proved that biology doesn't need to mirror Earth. It only needs to fulfill physics. And physics is generous. Hydrogen, being everywhere, means life could be everywhere too. Not just in oxygen-rich blue planets, but in pink skies, in methane seas, in the quiet glow of gas giants. So K218b didn't just expand our understanding, it expanded our humility. We began to see that life is not an exception carved into the universe. It's a continuation of its logic. The same laws that make stars burn also make cells breathe. The same symmetry that shapes galaxies also shapes DNA, or whatever replaces it elsewhere. And, there's something almost spiritual about that thought, though it comes from science. Because if life is written into the language of hydrogen, the first element, the first voice of the cosmos, then everything that followed, every heartbeat, every word, is just a translation of that primal note. Life isn't a miracle placed upon physics, it's physics singing through matter. So what would hydrogenic life look like? Scientists have speculated that it could exist as floating membranes, like bubbles in a vast gaseous ocean, gathering energy from starlight that filters through the haze. Instead of chlorophyll, they might use catalysts tuned to the infrared glow of their red star. Instead of lungs, they could respire by exchanging hydrogen and methane. Their metabolism would be slower, smoother, less fire, more rhythm. Well, and, maybe they wouldn't see or hear as we do. Maybe they would sense changes in chemical gradients as emotion, or shifts in temperature as thought. Maybe communication would be diffusion, a blending of presence rather than words. That idea sounds poetic, but it's deeply scientific too. Because communication, at its core, is the movement of information. And information doesn't need language, it needs balance. Perhaps those beings wouldn't even have a sense of individuality. Perhaps their intelligence would be collective, an entire atmospheric layer thinking together, responding as one organism that spans the planet. It's not just possible, it's probable. On Earth, we already see hints of this in fungal networks, coral reefs, and swarms of neurons. So maybe consciousness is not confined to skulls. Maybe it's the universe becoming aware of itself wherever chemistry reaches complexity. And, that realization humbles us again. We thought life required land, oceans, oxygen, and sunlight. But on K218b, it might require none of those things. It's not about comfort, it's about coherence. Not about resemblance, but resilience. The cosmos doesn't play favorites. It creates endlessly, everywhere, in whatever form physics allows. As Webb continued to study the planet, it found that the hydrogen wasn't static. It circulated, rising and falling like a slow breath. The outer layers cooled, the inner layers warmed, and the entire world pulsed in harmony with its orbit. That rhythmic balance kept its temperature stable, 49 degrees Celsius, year after year. It's as if the planet itself participated in the maintenance of life. And, well, that's the most beautiful symmetry of all. The same element that began the universe now sustains it. Hydrogen, the first spark, becomes the final thread connecting stars, planets, and perhaps beings that look up and wonder, as we do. The revelation of hydrogenic life shifted science again from, can life exist? To, how can it not? Because once you see that life follows physics, not accidents, you begin to understand that existence itself is inevitable. It's not just that hydrogen allows life, it invites it. Every atom, every bond, is a potential beginning. Well, and that's what K218b has given us, not certainty, but continuity. It reminds us that we are not anomalies, we are outcomes. That life is not local, it's universal. The moment Webb captured that faint spectral signature, it didn't just reveal another world. It revealed the unity of all worlds. And, as the telescope turns its mirror toward the next target, toward the next whisper of hydrogen drifting through the void, we begin to sense that each discovery is not a destination, but a doorway. A doorway leading deeper into the same cosmic truth, that life, in all its forms, is the universe remembering itself, again and again, through the quiet hum of the simplest element, waiting to be understood a little more in the chapters yet to come. Beneath the hydrogen skies of K2-18b, the light fades into a permanent twilight, a soft, endless shimmer where day and night are not opposites, but gradients of the same glow. The deeper one imagines sinking through its atmosphere, the more the world begins to change. Layers of hydrogen thicken into veils of mist. Temperature rises slowly but steadily, and somewhere far below, beyond the reach of any telescope, there lies what scientists now call the infinite ocean. It's not an ocean in the earthly sense, with waves and tides, but a vast global expanse where hydrogen and water blend in impossible harmony, creating an environment both alien and strangely familiar. Well, when the Webb telescope hinted at the presence of liquid water beneath those dense clouds, it was as if the planet itself took a breath. Water, after all, is the stage where chemistry learns to dance. Every molecule of life we know, DNA, proteins, sugars, was born in water's embrace. So when we imagine oceans on K2-18b, we imagine not silence but potential, the slow conversation between hydrogen and oxygen that could, over billions of years, become something alive. That and that possibility, even if just theoretical, shifts everything we think we know about the origins of biology. And, the most striking thing is not that these oceans might exist, but that they might endure. Earth's oceans are fragile. They evaporate, freeze, acidify. But K2-18b's ocean is sealed beneath kilometers of hydrogen, protected from the raw vacuum of space. The planet's pressure acts like a guardian, keeping the water from boiling even as the temperature climbs beyond what life here could endure. It's not just stability, it's resilience. The ocean doesn't merely exist, it persists. Imagine diving through that vast, lightless sea. No sunlight filters through, no surface to reflect stars, only the slow, rhythmic motion of chemistry happening in darkness. On Earth, life began in similar shadows, at the edges of hydrothermal vents, where heat met cold and minerals met water. The first cells were born not in comfort, but in contrast. That same tension might exist here, deep within K2-18b, where hydrogen molecules dissolve into water and recombine endlessly, releasing small pulses of energy, tiny, steady sparks that could feed the beginnings of metabolism. That, concept isn't fantasy. It's physics. When hydrogen reacts with oxidized compounds like carbon dioxide in the presence of water, it forms methane and releases energy. On Earth, entire ecosystems survive on that simple chemistry. So if K2-18b's ocean floor has minerals or catalytic surfaces, it could host similar reactions, slow, patient processes that, given enough time, might weave molecules into meaning. Well, some scientists call this the second Genesis model. It suggests that wherever water and energy coexist, life is inevitable. It doesn't matter whether the solvent is salty, acidic, or buried beneath a sky of hydrogen. What matters is persistence, the steady cycling of reaction and renewal. And K2-18b, with its endless ocean and thick protective shroud, could be the most persistent world we've ever found. In simulations, the planet's temperature gradient allows for stable convection, warm currents rising, cool ones sinking. This motion circulates nutrients, prevents stagnation, and could even create localized zones of chemistry rich enough to self-organize. The same way Earth's tides and currents once nurtured amino acids, K2-18b's hydrogen tides might nurture something new. And, there's a strange poetry to that. Life, at its heart, is circulation. The planet breathes, the ocean stirs, the chemistry turns, and in those turning patterns, structure emerges. That's what the early Earth did too. It turned chaos into rhythm. And Webb, by capturing faint signatures of water and methane, has given us reason to believe that rhythm may be universal. Well, and it raises an uncomfortable question. If life is possible in hydrogen oceans, then maybe it's not rare at all. Maybe it's everywhere, hidden beneath layers we can't yet see. The challenge isn't to find life, it's to recognize it when we do. Because we've always looked for reflections of ourselves. Oxygen breathers, carbon-based organisms, sunlight seekers. But K2-18b forces us to see differently. Its ocean doesn't sparkle. It hums. Its biology, if it exists, might not build bones or brains, but networks, lattices, systems that communicate through chemistry rather than thought. And that means, perhaps, that our definition of alive is too narrow. Life might not always rise to the surface. It might stay deep, content to exist without needing to be seen. The universe doesn't require spectacle for significance. Sometimes it hides its miracles in silence. And, well, if those oceans are as deep as models suggest, hundreds of kilometers, thousands of atmospheres of pressure, then beneath them could lie something even more mysterious, a layer of high-pressure ice, not frozen in the way we know it, but dense, flexible, and warm. It could act as a bridge between water and the rocky core below, transferring heat, minerals, and maybe even forming conduits, pathways where energy seeps upward, feeding the chemistry above. On Earth, we call those black smokers, vents that breathe minerals and warmth into the sea. On K2-18b, they might be the same, but slower, subtler, as if the planet itself whispers its energy into the water. That whisper might be enough, because life doesn't begin with noise. It begins with repetition. Molecules meeting, parting, meeting again, until one day they choose to stay. The ocean gives them time to find each other, to evolve from randomness into rhythm. When scientists ran thermal models of K2-18b's ocean, they found something extraordinary. Even at its most extreme depths, the temperature could remain within the range where complex molecules stay stable, not just survive, but assemble. The combination of hydrogen's reducing environment and moderate heat creates what some call chemical patience. Reactions don't burn out quickly. They linger. They adapt. And that patience, that cosmic slowness, could be the key to creation. Well, and it changes how we think about time itself. On Earth, evolution feels fast because we measure it against our short lives. But on a planet like K2-18b, time might flow differently, not just physically, but chemically. With less radiation, less destruction, molecules could accumulate for eons before taking their first step toward life. That, slow unfolding means intelligence there, if it ever arises, could be ancient beyond imagination. Millions or billions of years older than us, living beneath the same oceans that once taught them to endure. And, yet, when we look at K2-18b through Webb's lens, we see only a reflection of light, a thin signature across the void. We don't see the waves, the pressure, the quiet revolutions happening beneath. But maybe we don't need to. Maybe it's enough to know that somewhere, right now, chemistry is learning to speak again in a new dialect of water and hydrogen. The ocean of K218b isn't just a scientific curiosity. It's a mirror. It shows us that life isn't tied to comfort or sunlight. It's tied to structure, to persistence. Every drop of water, every atom of hydrogen holds within it the memory of creation. And when those elements mix under the right pressure, they remember how to begin again. Scientists sometimes call it the long dawn. The idea that worlds like K218b are still in their prebiotic phase, not yet alive, but awakening, slowly, imperceptibly. Webb's data might have caught the first glimmers of that awakening, the chemical murmurs before biology takes shape. It's not just a world, it's a sentence paused before its first word. And, perhaps that's why this discovery matters more than any before. Because if K218b's ocean is real, if beneath those clouds there truly lies an endless sea where hydrogen and water intertwine, then life is not a question of if. It's a question of when. The universe isn't waiting for permission to create. It's already doing so, everywhere, all at once, in depths we can't yet reach. Well, and as Webb continues to refine its gaze, as new instruments join in the search, humanity stands at the edge of understanding not just life's existence, but its essence. What began as data has become a kind of reflection, a realization that life doesn't belong to us. We belong to it. We are one chapter in a story written by oceans that stretch across stars, and somewhere beyond that hydrogen haze, beneath those endless tides, chemistry is still writing, still learning the language of being. Its words rise slowly, molecule by molecule, toward the surface of light, waiting, just waiting, for someone out there, or maybe right here, to listen closely enough to hear them continue in the next breath of discovery. When scientists began to study the red dwarf star that K218b orbits, they realized they weren't just studying a star, they were studying time itself. The star, known simply as K218, is small, quiet, and remarkably patient. Unlike our own sun, which burns fast and bright, this one glows with a dim, steady persistence. It's cooler, yes, and smaller, but it will live far, far longer. Trillions of years longer, perhaps. And, well, that longevity changes everything about how life might emerge and evolve around it. Well, the first thing to understand is that red dwarfs like K218 are born from the same cosmic nursery as every other star, but they never rush. They ignite slowly, holding their fuel close, stretching their light across unimaginable spans of time. The sun, for example, will die in about 10 billion years. K218 could burn for more than 100 times that. So while our world races against the ticking clock of stellar decay, a world orbiting K218 has all the time in the universe, literally, to become whatever life wishes it to be. That sense of time redefines evolution itself. On Earth, evolution is fast because destruction is fast. Extinctions come suddenly. Asteroids, ice ages, volcanic winters. But on a planet like K218b, orbiting a stable red dwarf, the pace of change could be glacial. Not centuries or millennia, but epochs stacked upon epochs. That slowness might give rise to creatures of unimaginable complexity, not through haste, but through patience. The kind of patience that allows molecules to perfect themselves. And, that patience is only possible because of stability. K2-18's light may be faint, but it's constant. Its energy doesn't surge violently the way young stars often do. It hums rather than burns. For life, that means safety, a predictability that allows ecosystems to flourish without fear of extinction by solar tantrums. Well, mostly, because red dwarfs have tempers too, especially in youth. In their early billions of years, they flare, intense bursts of radiation that can strip atmospheres and scorch worlds. But K2-18 is older now, quieter. Its storms have subsided, its energy balanced. The planet K2-18b, orbiting at just the right distance, neither too close to be vaporized nor too far to freeze, sits in what scientists call the habitable zone. The light that reaches it is soft and infrared, invisible to human eyes but perfect for nurturing warmth through hydrogen clouds. And, that gentle warmth is constant. No harsh day-night swings, no deadly winters, just a steady, enveloping glow. It's not sunlight as we know it. It's slower, deeper, more intimate. The world is not lit by brilliance, but by endurance. And that difference changes the rhythm of everything living, or that could live there. Photosynthesis, if it exists, wouldn't depend on visible light, but on infrared absorption. Plants, if we can call them that, might not be green, but black, absorbing every photon possible. Life there wouldn't chase energy. It would gather it, patiently, methodically. That, patience extends to the planet's orbit, too. Because K2-18's gravity is weak, K2-18b's orbit is slow. A single year there might feel eternal. And, well, perhaps that influences consciousness, if such a thing exists there. We measure our lives in moments, in days, in seasons. But on K2-18b, life might measure itself in cycles of light that last decades. Imagine a civilization where a sunrise is a century-long event, and sunset is a memory passed through generations. Well, the slow dance between K2-18 and K2-18b isn't just poetic, it's profoundly scientific. That stable orbit keeps temperature constant, allows oceans to remain liquid, and prevents catastrophic climate shifts. The red dwarf acts as both parent and guardian, its gravity anchoring the world in a delicate equilibrium. Even its low luminosity helps. Less radiation means fewer mutations, fewer collapses. Evolution proceeds, but gently, like the shaping of stone by water. And, what's remarkable is that K2-18's long lifespan means its habitable zone doesn't move much over time. On Earth, the sun grows hotter every billion years, slowly pushing the habitable zone outward. In a few billion more, our oceans will boil. But K2-18's light remains almost the same for trillions of years. So if life begins there, it doesn't have to rush. It has time to learn, to adapt, to fail, and begin again. That realization has changed how scientists think about the sweet spot for life. It's not just about distance from a star, it's about the lifetime of opportunity. A red dwarf gives more of it than any other kind of star. And yet, paradoxically, that same longevity makes it hard for us to observe, because evolution that slow, that deliberate, may still be in its infancy, even after billions of years. And, it's humbling, really. We often think of life as something that bursts forth, that conquers its environment. But on a world orbiting a red dwarf, life would likely whisper instead of shout. It would thrive not by domination, but by synchronization. The ecosystem wouldn't fight the planet. It would become part of its rhythm. It's not just life living under a sun. It's life living in harmony with time. Well, and when you think about that, really think about it, it makes Earth's story seem frantic. Our planet has been alive for only 4 billion years, and already we're anxious, fleeting, self-aware. But imagine a civilization that grows beneath K218's calm light for 10 trillion years. Their perspective on existence, on mortality, on purpose, it would be beyond comprehension. They would not measure progress in centuries or even in eras. Their art, their thought, their language would unfold like the orbit of their world. Slow, deliberate, infinite. And yet, as strange as that seems, it also feels familiar, because the universe itself moves that way, slowly, patiently. Stars form, burn, fade, and return to dust. The galaxies spin, not in haste, but in inevitability. Perhaps red dwarfs are the universe's way of ensuring continuity, a way to keep life burning even after brighter stars die. That idea, that the smallest stars might host the longest stories, turns our sense of significance upside down. We've always looked to the brightest objects for meaning, the grand, the visible. But maybe, just maybe, the real miracles are happening in the quiet, in the dim red glow of the most patient stars. It's not the blaze of light that defines creation, it's the endurance of it. And, endurance is what defines K218b's parent star. Its spectrum tells us it's stable, its rotation slow, its magnetic field calm. These qualities don't just allow life, they encourage it. Radiation levels are low enough for atmospheres to survive, and the gravitational balance is gentle enough to avoid tidal destruction. The entire system feels intentional. Not designed, but balanced, as if nature itself were fine-tuning a cradle for persistence. Well, that might sound romantic, but it's deeply mathematical. Stability, like that, is rare in the universe. Most stars flare, collide, or consume their worlds. K218 does not. It gives without taking. Its energy doesn't demand adaptation through pain. It allows adaptation through peace. And, well, maybe that's why the discovery of K218b matters beyond its data. It's not just about whether life exists, it's about what kind of life the universe favors. Fast-burning or slow-growing? Fragile or enduring? The red dwarf suggests an answer. The universe prefers patience. It rewards longevity, equilibrium, harmony. So perhaps if we ever find life there, beneath the hydrogen skies, within the endless oceans, it won't look at the stars the way we do. It won't see them as unreachable beacons, but as familiar companions, slow and steady as their own heartbeat. For them, time would not be an enemy. It would be home. And that thought, well, that thought changes how we look at ourselves. We, who live under a restless star, in a brief, blazing moment of light, might realize that intelligence born under calmer suns could outlast us all. And yet, maybe we are connected, not by pace, but by purpose. Not just by existing, but by seeking. Because no matter how slow or fast, all life shares one instinct: to look upward, to wonder. And, in that shared wonder, across billions of years and trillions of orbits, the quiet red star and its world remind us of something profound. That creation is not a race. It's a conversation between time and life, between silence and awareness. The glow of K218 continues, unwavering, while we on Earth watch from afar, our brief sparks of existence reflecting in its ancient light. And as Webb turns its golden eyes toward that dim red sun again, searching for more whispers of hydrogen and water, of chemistry and potential, it feels as though the universe is inviting us to slow down, to listen, not to the brightness of creation, but to its patience. And somewhere beyond that light, Perhaps hidden still beneath those calm hydrogen clouds, a world waits, not rushing, not fearing, just existing, ready, quietly ready for the next chapter of discovery to begin. The data from Webb had started to form a strange rhythm, a pattern that scientists could no longer dismiss as coincidence. Across dozens of exoplanets, from K2-18b to worlds orbiting distant red dwarfs, the same temperature kept reappearing. 49 degrees Celsius, 120 Fahrenheit. The number felt almost poetic, almost too deliberate. And, well, that repetition whispered something profound. The universe wasn't random. It was consistent. It was organized. Well, that realization, simple as it sounds, shook astronomy. Because, you see, in science, pattern means principle. When the same conditions arise again and again across billions of miles, it's not chaos, it's law. And that made researchers wonder if there was a hidden symmetry in creation, a balance that quietly shaped the environments where life could flourish. Not just on one planet, not just in one solar system, but everywhere, as if the cosmos itself were tuning its instruments toward harmony. At first, they called it coincidence. After all, temperature depends on distance from a star, on atmospheric density, on albedo and pressure. But when Webb's readings came back, planet after planet, orbit after orbit, each within the same narrow thermal band, the data began to defy dismissal. It's not that the worlds were identical, it's that they were compatible. Compatible with chemistry, with complexity, with the slow architecture of life. And, that changed the question. Scientists no longer asked if life could exist elsewhere. They began to ask why it keeps being invited. The universe, it seemed, wasn't hostile. It was hospitable. The repetition of temperature, composition, and balance hinted at a universal rule. Wherever energy, stability, and time coexist, life follows. It's not a miracle, it's a mechanism. Well, some called this the cosmic equilibrium, a state where the physics of stars, the chemistry of gases, and the mathematics of orbits converge to create that narrow golden range where biology can awaken. And, if that equilibrium appears naturally, without intention, without design, then perhaps fine-tuning isn't proof of a creator, but proof of consistency. The universe doesn't need to be designed for life. Life is what happens when the universe works as it should. That, notion reframes everything. We used to think we were lucky, that Earth was an exception, a rare gem in a sea of emptiness. But maybe Earth isn't special at all. Maybe it's typical. The same physics that sculpted our oceans and atmosphere might be sculpting countless others. If K2-18b shares our temperature, our chemistry, even our patterns of disequilibrium, then it's not imitation, it's reflection. Some scientists, hesitant but hopeful, began using new language. They called it biological inevitability. The idea that the universe's constants, gravity, electromagnetism, thermodynamics, don't just allow life, they favor it. That perhaps life is not rare because it doesn't need permission to exist. It simply emerges wherever there's room. And, well, that leads us to the haunting beauty of it all. Because when you think about fine-tuning, not as divine precision, but as statistical necessity, it makes existence even more miraculous. It's not one act of creation, but countless ones, repeating endlessly wherever hydrogen meets light, and time is patient enough to wait. Well, when Webb compared K2-18b's data to other worlds, the evidence deepened. Planets orbiting different stars, different ages, different sizes, still shared this balance. Their atmospheres, though varied, carried echoes of hydrogen, methane, and carbon dioxide in similar proportions. Their thermal profiles hovered near the same average. The probability of that alignment being random fell to near zero. And, it began to look like something else. Like structure. A self-organizing universe. A cosmos that, through the relentless logic of physics, tends toward order, not chaos. It's not that everything is alive, but that everything leans toward the conditions that could make it so. That's when philosophy quietly re-entered the lab. Scientists who once avoided metaphysics began to whisper about purpose, not religious purpose, not intention, but direction. The idea that maybe the universe doesn't just expand, it evolves. It doesn't just exist, it refines itself. Stars forge elements, planets stabilize orbits, chemistry finds repetition, and out of repetition comes rhythm, and out of rhythm comes life. And, in that rhythm, something startling emerges. Universality. The temperature balance isn't just a number, it's a signal that life isn't confined to Earth's blueprint. It could thrive under different skies, in different oceans, following the same fundamental pattern but playing it in another key. Well, that means the fine-tuning question, whether the cosmos was made for life, was never about intention at all. It's about resonance. The same equations that describe energy and entropy also describe the boundaries where life can dance without dissolving. The universe doesn't choose. It oscillates. It experiments endlessly until harmony appears. Think of it this way. Every planet is a note in a cosmic symphony. Some notes are too sharp, some too flat. But every so often, just often enough, there's one that rings true. And it's not just one note. It's millions, scattered across time and space, each carrying the same melody of warmth, water, and wonder. And, this repetition, this strange self-similarity, could mean that life is a fractal. Patterns repeating across scale, from molecules to galaxies. The same geometry that shapes spiral shells shapes spiral galaxies. The same feedback loops that stabilize ecosystems stabilize atmospheres. Life doesn't emerge against the universe, it emerges with it. Well, it's unsettling though, because if the universe is structured to nurture life, then it might also be structured to end it, to recycle it, to keep the process moving. Stability allows creation, but it also ensures renewal through destruction. So maybe death, extinction, and collapse aren't failures. They're balances too. The cosmos doesn't cling to form. It cherishes transformation. In this view, fine-tuning isn't evidence of design. It's evidence of equilibrium, a constant negotiation between creation and entropy. That's why K218b matters so deeply. It sits right at the intersection of balance. Not too hot, not too cold, not too unstable. It is, in every measurable way, a microcosm of the universal pattern. And, well, that pattern might mean there's a golden zone not just for temperature, but for time, for chemistry, for consciousness itself. The 120-degree equilibrium may be just one piece of a greater symmetry, the symmetry of existence. Well, as the data poured in, Webb's findings began to suggest something even bolder. Maybe fine-tuning isn't unique to life-bearing planets. Maybe the constants of the universe are tuned to maximize complexity wherever possible, from galaxies to cells, from atoms to awareness. It's not about survival, it's about expression. The universe creates not because it needs to, but because it can. And so, scientists began to talk about emergence, the idea that order arises spontaneously from simple rules. Just as snowflakes form intricate patterns from water's geometry, entire biospheres might form from the logic of physics alone. The boundaries between chaos and order are where beauty happens. And, maybe that's the real secret of the cosmos. It's not fine-tuned for life. It's fine-tuned by life. Every world that breathes, every molecule that replicates, pushes the balance forward, reshaping probability itself. The universe doesn't just give rise to life. Life gives rise to meaning, and meaning reshapes how the universe is seen. Well, if that's true, then K2-18b is not an accident. It's an echo of the same law that birthed Earth, the same balance that shaped us. The golden temperature isn't coincidence. It's a fingerprint, a shared pulse between distant worlds, beating to the same cosmic tempo. And, as Webb prepares to gaze farther still, to find other worlds repeating the same quiet music, we begin to suspect that pattern extends even deeper, beyond planets, beyond stars, into the structure of consciousness itself. That, maybe the universe isn't observing us. We are the universe observing its own organization, its own coherence, its own reflection. So when we look up at K2-18b, shimmering faintly in the distance, we're not just seeing another world. We're seeing confirmation that creation isn't a singular event, but an ongoing conversation. A conversation between matter and mind, between physics and possibility. And as that thought deepens, as it turns and expands in the silence of space, it leads naturally, quietly, toward the next realization, the one that awaits beyond K2-18b, when we begin to ask not how many worlds are alive, but how many worlds are aware that they are. When the data from K2-18b settled into clarity, the excitement that filled the scientific community wasn't just about one world, it was about what came next. Because if one planet, orbiting a small red star in the quiet of the Leo constellation, could sustain life-friendly chemistry, then, well, what stopped the others? What stopped there from being hundreds, thousands, maybe billions more? And, well, that thought was both exhilarating and unsettling. Well, the numbers began to unfold like a revelation. Within just 200 light-years, barely a grain of sand in the cosmic desert, Webb had identified dozens of exoplanets with similar compositions, stable hydrogen envelopes, balanced temperatures around 49 degrees Celsius, and traces of water vapor in their skies. That pattern couldn't be random. It suggested not one miracle, but a rule. The universe wasn't stingy with its conditions for life. It was generous. It was repeating itself over and over in quiet precision. That realization turned astronomy from exploration into mapping, a cartography not of continents, but of possibility. Each exoplanet discovered was no longer a point of light. It was a clue, a coordinate in the architecture of creation. And scientists began to whisper a new question. If this pattern holds true so close to home, what happens when we look farther? 10 times farther? 100 times farther? How many worlds are out there quietly breathing under alien suns? And, the projections soon became staggering. Statistical models, based on Webb's early findings, suggested that within our galaxy alone, there could be billions of planets inside their stars' habitable zones. Not millions, billions. And if even a fraction of those shared K2-18b's balance of chemistry and heat, then life wasn't an exception at all. It was the default. The cosmos didn't need to try hard to make life. It would need to try hard to avoid it. Well, that's when the language began to change. The word habitable no longer meant Earth-like. It began to mean compatible with life in some form. Because, what Webb had shown was that life doesn't demand a carbon copy of Earth. It demands equilibrium, stability, energy, and time. It's not about oceans like ours or air like ours. It's about environments that let complexity grow, however strange, however different. Think of it this way. For centuries, we searched for twins of Earth, for familiar faces among the stars. But what Webb found was something far more profound. Worlds that weren't mirrors, but siblings. They didn't look like us, but they carried the same inheritance of physics, the same potential for chemistry to dream itself into biology. And, maybe that's what makes the discovery so deeply human. It teaches us that life's family tree stretches beyond species, beyond planets, beyond imagination. The shift in thinking spread quickly through science. Instead of, are we alone? The question became, how far does this go? The Drake equation, once a speculative tool, suddenly felt too modest. New variables emerged. The longevity of red dwarfs, the prevalence of hydrogenic atmospheres, the rate of chemical disequilibrium detected by Webb's sensors. Plug those numbers in, and the results were almost absurd. Trillions of possible living worlds in the observable universe. And, well, with that realization came humility. Because, if life is common, then intelligence might not be rare either. We've always assumed that thought, consciousness, language, those were ours alone. But what if they're inevitable outcomes of the same cosmic pattern? What if awareness is just the universe's next natural step after chemistry stabilizes? It's not a question of if minds exist. It's a question of how many ways the universe has learned to think. Well, and, perhaps we've already brushed against those minds without knowing. Perhaps their signals aren't radio waves, but something subtler. Patterns in magnetism, fluctuations in starlight, whispers written in chemical rhythms. The irony is that in searching for aliens, we may have been listening for ourselves, for our own form, our own technology, our own way of communicating. But what if intelligence doesn't always reach upward? What if, somewhere beneath the oceans of K218b, awareness looks inward, patient, slow, content just to exist? When Webb sent back data from other planets, those orbiting stars smaller, dimmer, quieter than our sun, the similarities deepened. Each system seemed to hum with the same balance, the same delicate tension between order and entropy. And scientists began to suspect that this wasn't coincidence. It was emergence. The universe doesn't just create, it self-organizes. The way snowflakes form identical fractals from chaos, entire ecosystems might arise from cosmic inevitability. And, that changed everything. Not just astronomy, but philosophy. Because if life is everywhere, then so is meaning. Not human meaning, not moral meaning, but physical meaning, the kind written into the equations themselves. Life isn't an interruption of the universe's silence. It's the way the universe speaks. It's not the noise, it's the language. Well, some philosophers of science began calling this the continuum of being. The idea that every layer of reality, from atoms to galaxies, is part of one continuous expression. That, consciousness doesn't begin at the human mind. It begins wherever order can reflect upon itself. So when we say the universe is alive, we're not being poetic. We're being literal. Life isn't a rare phenomenon. It's the cosmos recognizing itself in countless forms. And, if that's true, then the discovery of K2-18b and its kin isn't just an astronomical milestone. It's an existential one. It suggests that we're not just observers in a vast, indifferent expanse. We are participants in a living, evolving system. We are not separate from the universe. We are its way of noticing, its way of wondering. The idea is dizzying, but grounding too. Because the farther Webb peers, the more it confirms a quiet truth. The universe doesn't build walls, it builds bridges. Every new planet found, every spectrum decoded, connects us to something larger, something ongoing. And so, when we map the stars, we are not just charting space, we are tracing consciousness itself, spread across time and matter. Well, and as 2025 unfolds, new instruments are being prepared to follow Webb's lead, to listen not for life as we define it, but for life as it defines itself. The search will not end with K2-18b. It will expand into constellations we've never imagined, toward worlds that might make us rethink what it means to be alive at all. And, maybe that's the quiet lesson in all this. That discovery is not about finding others. It's about remembering that others and us are the same process, expressed in different rhythms. We're all, in the end, made of the same patience, the same physics, the same endless curiosity. So as the next chapter opens, when telescopes turn their gaze beyond the faint red suns toward the colder, darker corners of the cosmos, the question will no longer be, where is life? It will be, what form of awareness is waiting for us there? Because the search isn't just out there, it's within the very light we follow, within the universe trying again and again to know itself a little more clearly. When the realization finally settled in, when humanity looked up at K2-18b not as an anomaly, but as a mirror, everything about our place in the cosmos began to shift. It wasn't just that life might exist elsewhere, it was that life, must exist elsewhere. And, the more we stared into the quiet darkness beyond our sun, the more it began to feel less like an abyss and more like a network, a vast, interconnected fabric of living possibility. Well, that thought alone changed everything about how we saw ourselves. The idea that we were special, singular, chosen, it softened. Because, if the same physics that created our oceans also shaped the hydrogen seas of K2-18b, then we weren't alone in the truest sense. We were part of something shared, something repeating. The atoms in our blood and the atoms in those alien oceans weren't strangers. They were siblings. When Webb sent back that faint spectral curve, hydrogen, methane, water vapor. The data wasn't just science, it was poetry. Each peak and valley told a story written not in words, but in wavelengths. It was as if the universe itself had been whispering all along, that the laws of nature are the same everywhere, and wherever they find balance, life will bloom. And, well, in that whisper, there was both comfort and awe. Well, as 2025 drew on, scientists began to see K2-18b not merely as a destination for future explorers, but as a reflection of what Earth once was, and perhaps what it will become. The composition of its air, the shimmer of its potential oceans, even its slow rotation beneath a red star, all seemed to echo an older, calmer version of our own beginnings. It's not that K2-18b is Earth's twin. It's that it carries the same mathematical signature, the same cosmic melody, played in another key. And that realization began to ripple beyond astronomy. Philosophers, poets, even theologians started to gather around the data, searching for meaning in the numbers. Some said it was proof that creation is infinite. Others said it was proof that creation is shared. And, both might be true. Because the discovery didn't diminish us, it expanded us. It reminded us that to be alive is not to stand apart from the universe, but to be the universe, briefly aware of itself. And, well, there's something deeply humbling in that. Because the more we know, the smaller we feel, but also, somehow, the more connected. The boundary between here and out there starts to dissolve. When light from K2-18b travels 120 years just to reach our telescopes, what we're really seeing is the past talking to the present, a kind of cosmic memory surfacing. We're not looking across space, we're looking across time. Well, and in that light, humanity's old fears, loneliness, insignificance, finality, they start to fade. Because, if life blooms wherever the conditions align, then death, too, is only transformation. The hydrogen in those alien skies could one day become water, and that water could one day cradle new awareness. Existence, it seems, doesn't end. It changes shape. It's not extinction. It's evolution in another form. That shift in thinking began to influence how we looked at Earth itself. We stopped seeing our world as an isolated miracle and began to see it as part of a continuum. The forests, the oceans, the air, they weren't fragile exceptions. They were expressions of a universal pattern. And that pattern is patient. It doesn't rush. It doesn't fear. It unfolds over billions of years, indifferent to the urgency of any single species. And, maybe that's the quiet lesson K2-18b offers us, that life's purpose isn't conquest or dominance. It's persistence. It's not about being the first to discover the stars, but the ability to endure long enough to understand them. The red dwarf at the heart of that distant system will burn for trillions of years. By the time our own sun fades, K2-18's gentle glow will still be warming its ocean world. And, perhaps life there will continue evolving long after we are gone, carrying forward the same cosmic conversation we've just begun to understand. Well, and that conversation, between light and matter, between chemistry and consciousness, feels endless. It's not just about survival. It's about awareness. The moment we realize that the same hydrogen that feeds a star also fuels thought, we stop seeing life as an accident. We start seeing it as the inevitable outcome of a universe that refuses to stay silent. So when Webb gazes at K2-18b, it's not just collecting data, it's collecting perspective. Every pixel, every spectral line, is a reminder that we're looking into a mirror that stretches across light years. And though the reflection is faint, it's unmistakably alive. The planet doesn't need to wave back or speak. It already does, through the quiet logic of its existence. And, for humanity, that understanding might be the most profound discovery of all. Because we've spent so long asking whether we're alone that we forgot to ask what alone really means. It's not solitude that defines us, it's connection. The universe has been connected from the beginning, from the first fusion of hydrogen in the first star to the breath you're taking right now. Well, that's why, as Webb prepares to turn its gaze to the next set of worlds, to the colder, dimmer systems hiding in the galactic dusk, there's a new kind of anticipation. Not just scientific curiosity, but a sense of kinship. Because wherever that next signal appears, it won't just reveal another world. It will reveal another version of the same story. The story of existence learning, again and again. How to become aware. Maybe in the end, that's what all of this is about. Not proving that life exists elsewhere, but understanding what life means here. It's not a question of discovery, it's a question of recognition. That when we find life beyond Earth, we are not meeting strangers. We are meeting reflections, other ways the universe has found to know itself. And, well, as humanity stands at this threshold, with the light of a distant red star flickering in the data and the hum of the telescope echoing through the dark, there's a strange calm. Because somewhere out there, under skies we'll never see, something else may already be looking up, wondering perhaps if they too are alone. And in that wondering, in that shared gaze across the infinite night, the story doesn't end. It only begins to circle back toward understanding, toward belonging, toward whatever waits just beyond the next horizon of light. In the end, when we look at the faint light reaching us from K2-18b, we're not just gazing at another planet across the void. We are staring into a mirror, one that reflects not our image, but our essence. Because what the James Webb Space Telescope has revealed is not simply a discovery of distant worlds, it's a rediscovery of what we already are. Life is not an exception in this universe. It's a language, a rhythm, a tendency written into the equations of existence itself. Well, and when we finally, quietly understand that, something shifts. The fear of loneliness, the ache of cosmic isolation, they dissolve. It's not emptiness out there, it's continuity. The same atoms that breathe within us burn in the hearts of stars and drift in the clouds around alien suns. The universe is not watching us. It's becoming us, again and again, in infinite variations. And, maybe that's the real miracle. Not divine intervention, but divine persistence. Hydrogen becomes complexity. Complexity becomes consciousness. Consciousness becomes wonder. It's not creation once, it's creation always. The cosmos keeps repeating the gesture that brought us here, the gesture of turning chaos into meaning. That's why K2-18b matters. Not because it might host alien life, but because it shows us that life is woven into the structure of things. Every world Webb uncovers, every spectrum it deciphers, is a line in the same universal poem. We are not reading about others. We are reading about ourselves, written across light years. Well, and as 2025 passes and Webb continues its quiet work, what it gives us is more than data. It gives us belonging. It reminds us that the distance between out there and in here is only an illusion, that the starlight we chase has already touched us countless times before. So perhaps the ultimate truth is this: the universe is not strange. It is familiar. It does not look away. It looks back. And every discovery, every new dawn on a faraway world is the cosmos whispering through the dark. You were never alone. You were always part of me. And somewhere, in that silence, as Webb drifts through its orbit, collecting the ancient light of creation, the universe keeps breathing, patiently, endlessly, waiting for us to understand that what we've been searching for has been here, within us, all along.